Hi, everyone. Thanks for joining this session. So tonight we're going to talk about how to switch from IT to data engineering. So I'm going to give everyone a quick introduction to data engineering, what data engineers do. And for those of you who come from my IT background, I would like to explain to you what kind of, what are some of the things you need to learn in order to switch to data engineering. And hopefully this session is helpful for everyone. If you have any questions along the way, feel free to type your questions in Zoom chat. You can raise your hand and ask directly as well. So let's get started. First of all, a quick introduction to WeCloudData, who runs these meetup events. We are launching a data engineer bootcamp. The next cohort starts in February. Just to let everyone know that these courses are available on the West Coast. The next cohort starts in April, but the next Eastern cohort starts in February. If you're interested in becoming a data engineer and you're considering taking a bootcamp, approach, you may want to consider WeCloudData's data engineering bootcamp. It comes in with both, part-time and full-time options, so you get the flexibility. Quick introduction to WeCloudData. We're a data and AI training academy. We have data science programs. The first cohort of the year has actually just started in January, actually last week. And the next cohort start in April. We have BI and data analytics bootcamp as well. If you would like to learn how to do data visualization and storytelling with Tableau, Power BI, as well as SQL and Python. We cover a lot of use cases in this program. Next cohort will start in April. And of course, I believe you're here for data engineering. So if you'd like to get a certificate in data engineering, we have a 6 months part-time program, and you can keep your full-time job while spending time on learning data engineering, upskilling yourself. There are a lot of things you need to learn if you want to become a data engineer. So a part-time program might fit your need better. So again, we have new cohorts starting in February, April, and also May in 2 different time zones. And if you're interested in becoming a machine learning engineer, if let's say you come from a data science background, and we have a very advanced machine learning engineering program that covers machine learning operations, computer vision, and natural language processing as well. All right, that's about it. Well, let's get started. What is data engineering? I think with applications of IoT, and even Web3, right? Social media, all of these applications we use on a daily basis, they generate data. Last time I checked, I believe back in 2022, people generated about 94, I believe it's zettabytes of data. That's a lot of zeros. That definitely, generates the demand for analyzing these data. And of course, the first thing we need to solve is to collect and ingest these data into data systems. But of course, companies do this, in many different ways. The demand of data engineering is not going to linearly grow, right, as the demand of data grow. But at least I think it's somewhat, positively correlated. A big part of data extraction and data ingestion can actually be automated, and I believe it should be automated so that data engineers can focus on writing code to orchestrate pipelines and do things that actually matters more. So let me give you a quick introduction to data engineering, but it's basically the process of collecting, ingesting, storing, and transforming data. And of course, along the way, we need to comply with Privacy Act. We care about the user privacy. So some of the data needs to be hashed, need to be encrypted. A lot of data cleaning needs to be done to make sure that the data is of good quality. Data modeling is a big part of data engineering because we need to do the modeling right so that access to information can be more efficient. So it's a pretty complex process. I think the best way for me to give you a high-level overview of the data engineering process is probably, just some sort of whiteboarding. I did this in another session in the past. Just to save time, I'm just going to show you the overall picture. And then we're going to dive a little bit deeper as we move along with this talk today, because we will talk about, the kind of skills and tools you need to learn if you come from different, IT background. And let's wait for that. For now, I just want to give you an overview of, this process of collecting, ingesting, and processing, transforming data. Let's start from the top left corner. And so imagine this is a B2C business. And any type of B2C business will have an online presence. They have products they're selling, right? So they definitely have product team. And when you are selling products to customers, then you have CRM systems, customer relationship management systems. You'll definitely do marketing, Google advertising or Facebook ads to sell the product, to create awareness. And of course, in the back end, you have operations, finance, accounting, and you have the back-end engineering team to build applications and the platforms. But of course, as a data engineer, we're not really generating or creating these software applications, right? What we're trying to do is to at least we will begin from data extraction. But first of all, I think as data engineers need to understand where data come from, and data engineers need to understand data sources very well. I'll give you 3 examples. Let's say this company has a web application, right? Maybe it's built using Ruby on Rails, Node.js, or even Python Python tools. And of course, whatever web applications we build, you need to have a backend database. Right? It could be a NoSQL database like MongoDB, but it can be a relational database such as PostgreSQL. So a lot of the application data, customer data might be stored in the PostgreSQL database. Think of it as your operational database, right? And it interacts with your web application. That's one type of data sources. And a company might be using CRM tools, right? Because after the marketing team has done a great job, it generates a lot of leads. So the sales team will need to basically stay in touch with customers and try to sell the products to these customers and convince them to subscribe to the service, right? Or maybe buy product from the website. They might be using sales tools such as Salesforce or HubSpot. And when you work with Salesforce, it's a SaaS platform, right? Software as a service platform. So you just need like a login credential. You need to have the right permission, and you can start to, input data and start to contact your customers and maintain a customer relationship. And it would be great if the data from Salesforce can be ingested into your data systems as well, so that you can, cross-reference. And a lot of these CRM leads data are very important for the company to gain insight into the sales process. Right? So we'll talk about that briefly. Another type of, data input might be, data coming from APIs. Right? If the data is not available from some sort of API, you may want to do web scraping. Maybe the data is coming from the web. Right? So you might be using Python, Scrappy, or using Selenium and Beautiful Soup to do web scraping at scale. There are also other marketing tools, right? Email campaigns, campaigning tools using MailChimp, for example. So all of these software, web applications, right? They generate data, and the data engineers will basically need to understand how to extract data or collect data from these sources. Because the ultimate goal is to put all of these data in the same place, right? Whether in a data warehouse or in a data lake, because your data science team or data analytics teams will need to build reports, dashboards. They might want to leverage data from different sources, right? Cross-reference them, join them, merge these data, and then they build features for machine learning purposes so that it can generate predictive insights. So the first step is data collection or extraction, right? If your data is stored in databases, then data engineers can, work with the software engineers or database experts to set up the CDC process, change data capture. And sometimes data engineers might need to work with different APIs from the SaaS platform. But even better, as I said, part of the data extraction process should be automated. So we can work with tools such as Fivetran, Apache, Airbyte, right? These are basically connectors, platforms that has hundreds of connectors, and you just need to put in the credential, and then it will be able to pull the data directly or periodically from these databases or SaaS platforms and ingest that into your data warehouse. Or data engineers sometimes need to write their own connectors because Fivetran doesn't support that data source. Maybe it's a less well-known data source, and then you have to write the connectors yourself. And sometimes data engineers need to write Lambda functions if they're getting data from APIs, right? For example, getting Twitter data. So these actually keeps data engineers pretty busy, but there are obviously great tools and platforms out there such as Segment, right? Fivetran that help you, that make data engineers' life easier. So I wouldn't say this is where data engineering generates the most value, because I think the data will still need to be cleaned and transformed before it become valuable, right? But this is absolutely a critical step, and data engineers are expected to be able to do this, right? They might not be the only person working on this, but it's definitely data engineers' responsibility to set up this kind of data ingestion and extraction process. And when we work on large-scale problems, right? A lot of times data come in real time. So we're not only pulling data on a periodic basis. You might want to ingest streaming data directly into your systems. This is where data engineers might need to set up streaming tools, right, such as Kafka, or Kinesis. Data engineers don't need to be the platform engineer. It's slightly different, right? Data engineers are still working with data, but they might actually need to help software engineers to ingest data into to the Kafka cluster. Or a lot of times it's the software engineers and developers who do that. But data engineers will definitely need to consume the data and apply data transformation on streaming data using technologies such as Apache Spark and Spark streaming. When it comes to data ingestion, there are different types of, different schools of thoughts right now in the market. Some companies prefer a data warehouse approach. They call this the modern data stack, right? So it's essentially, Fivetran for data ingestions using different connectors. And the modern data stack applies an ELT approach, which means after the data gets extracted, they will load the data into the warehouse first, right? So the data lands in a staging zone in the data warehouse. And these are usually cloud data warehouses such as Snowflake or Amazon Redshift. And data engineers will be writing a lot of SQL scripts in this case to do data transformations. They might be using DBT to do the modeling, right, and automate the workflow. And so DBT, Fivetran, Snowflake, they're becoming very, very popular in the last few years. But of course, not every company will go with a data warehouse approach, even though companies, most companies have some sort of data warehouse. But for some use cases, right, some companies, especially when they deal with really massive amounts of data, they may actually want to ingest the data into data lake, right? Because they might be dealing with a lot of unstructured data, such as video, text, voice, the data that usually don't fit into a relational database very well. So you sort of need to ingest the data into a data lake, right? And on top of data lake, the new trend here is that there's a lakehouse architecture. So you can combine batch and streaming data together, and also give data lake the ACID transaction type of capability, right? So there are different projects that enables lakehouse architecture, such as Apache Iceberg from Netflix, Delta Lake by Databricks. There's also Apache Hudi, right, which is heavily used at Uber. So this is the big data approach, right? It evolved from Hadoop to Spark, Data Lake, and then later on, Lakehouse. And of course, Kafka is playing an important role in here as well if we want to do streaming data and analytics. This is more like a ETL approach, right? But with the Lakehouse, capability. So you will be using different tools. in the modern data stack world, you need to work with DBT, SQL, and Snowflake. But in a data lakehouse world, you might be working with Scala, writing Python code. You're going to be working with Databricks platforms maybe, or maybe writing Spark jobs in Amazon Glue. So there are many different open source tools that allows data engineers to build data pipelines and do ETL and data transformation. So that's the storage, right? So after we ingest data, it needs to be stored either in the data warehouse, or it needs to be stored in the data lake or lakehouse. And of course, after data land in the staging area, we need to process the data and transform the data. We've talked about this. So you can use Spark, SQL, different kind of tools to analyze these data. And of course, after the data engineers have prepared the data, right? They may actually help the data scientists to build interesting user profiles, right? So data scientists will be building predictive models, and as part of the process, data engineers may want to send these insights, useful information, back to the transaction systems. So a basic idea here is that let's say data engineers will send the data to the warehouse from the data lakehouse, right? Because data warehouse is typically relational databases. It's perfect for BI and data science. And data engineers will be doing all the heavy lifting stuff in the data lake, but eventually data can still be ingested into a data warehouse, right? This is more like an ELT approach. And data scientists and data analytics professionals will be doing all the magic here in the warehouse, and then they may actually save a bunch of important data and tables in the warehouse. And data engineers sometimes need to send these data back to the source systems. And this is the process of reverse ETL. So basically, you want to send the customer profile data or whatever enriched data back to Salesforce, right? And sometimes back to your web application or back to MailChimp, so you can do marketing campaigns. So there are some reverse ETL tools that allows it to do that. And this concept of reverse ETL has become quite popular in the last few years, even though companies have been doing this for many, many years. But high touch, right, census are some of the popular options out there for just reverse ETL purpose, and they specialize in that. So this is the end-to-end data engineering process. Along the way, there's data analytics, dashboard, Power BI, there's data science, machine learning, and AI. But as you can see, data engineering teams, right, are the team that brings the data in, right, pre-process the data, make sure the data is clean and well organized in the warehouse or data lake, and then they also help data science team automate a lot of the data pipelines. Right? This is the high-level workflow. But when data engineers work on projects, right, to ingest specific data, the actual data pipeline diagram might be very complex, and there are a lot of dependencies as well. So that's what data engineering is. Hopefully, that gives you an overview of what data engineers would do on a daily basis, and we'll dive a little bit deeper into these components later. There's a question, a private question. So many options in tooling, tools to do the same thing. How different are they, and how does one get agnostic about it? Right. So yeah, so that's a great question. So I think when it comes to data engineering, right, there are hundreds of tools. As a data engineer or sometimes data architect, the job is to decide what is the best tool to use for the company or for a specific project, right? And whenever we talk about a project, there are always constraints. There's the time constraint, there's the budget constraint, there's the human resource constraint, yeah. So sometimes you're making decisions based on the best options you have. As data engineers, you will definitely need to understand the pros and cons of many different platforms and tools. And I think on this diagram, it's pretty clear that, data warehouse, right, is a good choice for small to medium businesses because you can work with Fivetran and ingest the data into the warehouse directly. So the time that it takes to get insight on these data is much faster, right? You don't really need a full-blown data engineering team in order to do that. You just need maybe 1 or 2 data engineers, or even just 1 analytics engineer who can set everything up. And these are cloud-based tools as well. And so you can start, building tools and start to visualize the data and generate insight, right? This might be the best option for a lot of small to medium businesses, right? Because at the very beginning, they're still focusing on building the core web application. So they don't really have a big data team. So they want something always very fast, right? And paying the money for this kind of SaaS tools probably makes more sense because you end up saving cost. However, as your data grow and your problems get more complicated, company will start to want to have more flexibility. And this is when you start to enter the realm of endless choice of toolings, right? Because if you want to ingest data into the data lake, then you have to decide which cloud you want to go with, or are you going to build everything on-prem using Hadoop and Spark? Probably doesn't make sense, but unless the company really have massive amounts of data, because putting everything in the cloud may end up costing you more, like 3 to 5 years later, but it's so much cheaper to get started. But the company will need someone who's more experienced to make a decision here, right? And it depends on the situation. But again, then you're making decisions along the way, right? Should we go with AWS, GCP? And you have to do the research and you have to make a decision. If you choose to go with AWS, then how do you ingest the data? Do you need a Kafka cluster, or do you just go with AWS Kinesis and Lambda functions using serverless? Yeah, so I think part of the data engineering team's job is actually just to do a lot of research, benchmarking, and decide what's the best tool to use, because you're probably building something the company needs for the next 2 to 3 years, sometimes maybe just 1 to 2 years. And you still need to make a decision, right? The best decision for the short term, but also you're looking at your long-term roadmap and to make sure that you're not every day you're not building new legacy systems. And it's hard because there's so many different ways to achieve the same goal. And you obviously have to choose the right tool, and you're going to make mistakes along the way. And that's also learning curve. So that's why the interesting thing about data engineering is that when you look at these startups and companies, they actually, even though they adopt similar paradigm, but they end up using very different approaches and different tools to solve very similar problems. And sometimes it depends on the legacy systems. It depends on the team's capability as well. If you have more Python developers on a team, then you're probably less likely to adopt Scala. But for a software engineer, like a company that use Java stack, they'll probably would prefer to go with Java and Scala if they want to work on Spark projects. So it's tough to say which is the best tool. It all depends on the situation. But that's a fun exercise. I think every data engineer will need to go through in their career. And when you start to realize that you're actually helping the company making this kind of decisions, you're sort of more like working as a data architect now. And definitely you should ask for a raise when you're in that position. Okay, so we just explained, data engineering, the high-level process, right? Now, I would like to talk about data engineer. We start to see the convergence of engineering disciplines, right, in the past few years, because there's so many different titles, roles out there: data engineer, data analyst, business intelligence specialist, data scientist, SDE, DevOps engineer. And it turns out that data engineering is actually overlapping with some of these roles, right? It definitely overlaps with data science, even though the work they do actually is quite different. But they work usually, together, right, on solving big data, data science problems. And data engineers are most of the time are expected to, get the data prepared for data science team, or sometimes they will help data science team scale their Spark jobs, for example. Even though the scope of the work is different, but they do share a common set of skills, right? So both data engineers and data scientists will need to know Python. They need to be really familiar with SQL and working with cloud platforms. And they both need to know Apache Spark, for example, even though data engineers will be using PySpark in Scala to write MapReduce jobs and process big data for ETL purpose. And data scientists might be using Spark machine learning libraries to build distributed machine learning algorithms. So, but they do share a common set of core skills, right? And data engineer and DevOps engineer also, their skill set overlap a little bit. For example, DevOps engineers are in charge of the CI/CD process and help company do automation, right? To save cost and build more robust software systems. They need to know scripting tools, for example, Python. Right? They need to know how to do configurations, working with containers and Kubernetes clusters. And it turns out that data engineers sometimes need to do automation as well, right? They need to automate the data pipelines. If Apache Airflow, which is a data pipeline tool, if it's set up on Kubernetes, then data engineers sometimes need to be at least comfortable with Docker containers and Kubernetes clusters as well. But even though the work is, scope of the work is very different, but skill sets sometimes overlap a little bit here as well. They both need to know, for example, cloud platforms. The DevOps might be focusing more on the security and networking side, while data engineers probably just focus on working with the data platforms, in the AWS ecosystem. And data engineer and software engineers definitely they need to be able to code. And data engineer will write production grade pipelines as well. If you build Airflow DAGs, you want to make sure that you can do do testing, unit testing on your DAGs and on your Spark jobs as well. So in that sense, I think there's some similarities there as well. But of course, when software engineers work on data engineering problems or building data pipelines, it probably doesn't feel like they're actually building application, because it's going to be less sophisticated. But the emphasis is more on the data side, and some software engineers actually don't enjoy working with data. We're going to talk about that later, but it's all about finding the right fit. If you come from software engineering, for some of you, data engineer might not be a good fit. You might find it pretty boring. So you might be interested in AI and developing AI, chat GPT based, software. That could be cool. But there are a lot of data and software engineers who are actually very into big data. So they're interested in building streaming applications, for example. So it all depends. So what are the responsibilities and the core skills for data engineers? I think we touched on this a little bit already. I just want to explain this from a slightly different angle. So this workflow here, let's read it from the bottom, right? So it sort of describes the different deliverables of data scientists, data engineers, and machine learning engineers. First of all, as we said, data always need to be extracted from the source, right? So when you look at what a company will build, like the data products they build, well, you always need to figure out where the data come from, right? And when data gets ingested, it becomes the raw data, and we need to start making sense of these data. But processing raw data typically just means applying business logic, right? On your raw data, you might be using SQL, Apache Spark to process the raw data, but essentially you're just adding the business logic to process the data. And data gets transformed and become processed data, right? It can be stored in the staging area, it can be stored in data lake, and then data engineers will need to load that into, let's say, a data warehouse, and that becomes the data analytics data, right? I skipped a lot of details. For example, data engineers will probably need to work with database experts or analytics engineers to build the data models, right? If it's a dimensional model or building white tables for a data warehouse, but the data will need to be made available to the analytics team, right? So these are the analytics data sitting somewhere in a data warehouse or data lake. That's pretty much what the data engineers would do, right? And then the data analysts or BI specialists will be building reports and dashboard using these analytics data. So analytics engineers might be working on this, or BI data analysts, and the output of these work, right, are used by business, right, to understand the business performance, and they're going to use that for business decision making as well. So executives like this kind of dashboard, right? On the left-hand side, we'll see that data scientists will be leveraging the data prepared by the data engineers to build machine learning models. Right? It could be a clustering model to understand customer segments. It could be a predictive churn models to understand, to predict the risks of customers leaving, the company, stop using your products. And a lot of the models built by data scientists are experiments, right? But if they, there's a model they would like to push to production, sometimes it basically just means creating batch prediction. You're scheduling, a Spark job to run on a daily basis, to read data from analytics data warehouse, and then you do feature engineering, and then generate predictions using a pre-trained model. And that process needs to be automated, right? And it turns out that in many companies, it's done by the data engineer, right? So for example, data engineers might actually take the model created by the data scientist and just add that to their Airflow pipeline. So it generates the batch prediction on a daily basis. The prediction part, is not very sophisticated, right? The model has been packaged, so there's no mathematics involved. Data engineers can totally just do it and scale it for the data scientist. In some companies, this is done by the machine learning engineers and MLOps team, right? So there's a little bit overlap there. It just depends on how company run their data teams and machine learning teams. And if you look at the purple box here, the machine learning engineers tend to, work more on the, model deployment side, right? So there are two different types of machine learning engineers. One type of machine learning engineer, they focus on model tuning and training as well. Another type of ML engineers basically work like, ML ops, right? So they're machine learning, they're taking running machine learning, applications in production environment, and they're helping the data scientist, or they train the models themselves and they deploy the model as endpoints. And when things are running in production, then you have to do monitoring. There are a lot of things, you need to take into consideration. For example, the scaling of the algorithms and of the prediction engine, and also the latency of your model prediction, right? Predictive models. And the output of these work will be used directly in your mobile and web application if you build endpoints, right? Data can be shared with the third-party partners as well. So they can leverage the insights created by the data science team and use that for other purposes. And you're essentially selling the data as well. So yeah, so these are different deliverables for different type of data and AI jobs. Hopefully that helps you understand how important data engineering is, because that's the starting point. Before you can do machine learning, business intelligence, data analytics, you will definitely need data engineers to help company build the infrastructure and build the data systems. And sometimes these are called, software engineers in some companies, or platform engineers as well. Okay, so there are different types of data engineers as well. I think if you're considering getting into data engineering, I think you need to understand there are different types of data engineers. This is also related to the main topic of the day, which is, switching from IT profession to data engineering, right? The first type of data engineer is what I'd like to call ETL, ELT engineer, right? This is not new. In companies, many big companies, they have ETL engineers working on, different projects. They might not be using the latest tools, because if you work for a bank, they have a lot of legacy systems. They might be using IBM Data Stage, Oracle tools, or, the SQL Server related tools, SSIS, right? Or Informatica, for example. These are quite expensive tools. And they exist for a reason, and very powerful tools as well. But I think in modern engineering, recently we see more professionals from the traditional ETL, ELT background considering getting into data engineering. They've been doing data engineering essentially for years, but they would like to upskill themselves. Just learn more about Python, Scala programming, learn more about cloud and some of the modern packages and platforms people use in startups and tech companies, for example. a lot of data engineers work basically focus on ETL or ELT. So they help company extract data, transform data, and load the data into warehouse, whether it's data warehouse or data lake. That's one type of data engineer jobs. And I think it's very suitable for people coming from database and data warehouse or ETL background. And because you have a lot of experiences already, I think the principles are still the same. And they're really just upskilling yourselves to learn new tools. And once you get familiar with those new tools, it should be quite easy switch for ETL engineers coming from the traditional background. The second type of data engineers are what I call data savvy software engineers. Their job title might be still software engineers and developers, but they work with a lot of data. So for example, they might be ingesting data into Kafka, right, messaging queues. And the data savvy software engineers might be building streaming applications, right, writing Spark streaming applications jobs as well. These are software engineers who really likes working with data and building data intensive applications. There's actually a book that I would recommend to everyone. It's called Data Intensive, building data intensive applications. It's essentially like a data system design kind of book that it covers a lot of the data infrastructure and platform side of things. Yeah, in companies like Twitter, big tech companies, Facebook, a lot of data engineers, their job title is basically software engineer. So if you come from software engineering background, that would be like, and you're into data, that would be my recommendation. And the third type of data engineer are the BI engineers or analytics engineers, right? The title might be analytics engineer, BI developer, or data engineer. Just these are the engineers that work with mainly working with SQL, because most of the BI applications are built on top of data warehouses. So you're working with relational database systems, working with Snowflake, SQL Server, Synapse Analytics data warehouse, or even Google BigQuery. Right? Understanding of data modeling is very important. Dimensional models, building white tables, and recently DBT became pretty popular. So I think these are the folks who will be working on the modern data stack, and it's very much in demand as well. If you come from database background, you're familiar with SQL, I think switching to an analytics data engineer might be an easy switch for a lot of database experts. But of course, you can switch to ETL or building streaming applications or even machine learning engineering, but it's going to take just more effort and time. So I think you just need to find the right fit for yourself and what you're actually interested in. Another type of data engineers are basically machine learning engineers. Maybe the focus is not so much on building and training machine learning models, but I've seen people with data engineering job titles doing a lot of the ML engineering work. They're using Airflow to help companies to or data scientists to build and automate ML pipelines. And of course, Airflow might not be the best tool for ML engineering, but a lot of companies use that. Yeah, and they will be building endpoints, APIs, using Lambda functions and API gateways, or sometimes just build a Flask app or a fast API app. It all depends on the company's needs, of course. But this is another type of data engineer, I would say. There's a question from an attendee. Is it required to be a cloud engineer first to start as a data engineer? Definitely not. So I think cloud engineering is very popular nowadays as well. The difference here is that cloud engineer, I think the career path is, you can potentially become a cloud solution architect. So that means you're going to know more the cloud platforms in depth compared to a data engineer. And you're more specialized in one type of cloud, right? For example, if you become AWS certified, and then you know AWS better. And I've seen people having like certifications from different vendors. That would be cool. But I think cloud engineers, the focus will be more on, the application side. For example, writing Lambda functions, right? And working on the networking side, building VPC, figuring out databases and data storage. And cloud engineers need to know a little bit of everything, I think, and they play a very important role in supporting many other teams in the company. Different teams are all using, for example, Amazon Web Services. But cloud engineers are not necessarily the software engineers who actually built the applications, but they're also not the data engineers who actually work with data itself, right? So cloud engineers probably don't need to write SQL queries to run reports or automate data pipelines. And from a data engineer's perspective, I think data engineers will need to be familiar with different cloud platforms, but they're mainly focusing on working with the cloud, the data related tools. AWS has more than 100 different services, and data engineers will definitely need to know compute, such as EC2, Lambda functions, need to understand data storage, working with Amazon S3 databases, right? Working with Redshift, RDS, Lambda functions, EMR, Hadoop, and Spark, but all of these are data related, right? But data engineers probably don't need to worry about securities and VPCs and networking related stuff. So it's actually quite different. So I guess my answer is no, a data engineer don't need to be a cloud engineer first. All right. What are the latest trends in data engineering? I think I covered some of these today. If you're considering getting into data engineering, you have to know what's happening right now and what will happen in the next 3 to 5 years, right? Because if you look back, data engineering field is evolving so fast that tools that we used to teach and learn or use in 10 years ago is not used anymore. They just became all legacy systems, but it's quite typical, I think, in IT, right? And when companies move to the cloud, they are just, the tools, they're abundant with tools. There's so many different options. And of course, data architect and the engineers need to help the company to make some good decisions. But still, like, you need to keep adapting and learning new things. I think a lot of the fundamentals and principles are the same, but working as a data engineer, you may find yourselves keep constantly learning new things. Not necessarily on the same job though. Like, you would be lucky if your company, you worked on several technology migration related projects. For example, moving from on-prem to the cloud. I think through that project, you're going to learn a ton and gain a lot of experiences. And those are really nice experience to have, right? But typically, data engineers will probably need to switch job, 2 to 3 times if you would like to, have a more holistic view of, the end-to-end data engineering experience. Because if you end up working for a company that only use AWS and using serverless, then you'll get specialized in that. But it doesn't mean that that company use Apache Spark and streaming data, building that kind of application, or the company may not even use data warehouse, right? So you may want to join another company to work on modern data stack. I don't know, but all I'm saying is it's quite exciting time right now. So let me share some of the latest trends, with you. The first trend, and I think even though we live in 2023 now, so many companies have already adopted cloud, but still there are a huge amount of opportunity out there, for data engineers and platform engineers and cloud engineers to help startups, traditional businesses, right, to migrate from on-premise to the cloud. This is going to last for many, many years. Yeah, so in this case, I think data engineers will be focusing on, the data migration part, right? The cloud, such as AWS, has, they have cloud data migration tools and services that will make data engineers' life so much easier. But, real life is always messy. Like, these tools are powerful and they're automated, but you're always going to run into lots of problems when you actually start to work on this kind of projects. But even if you want to start a consulting company, this could be a good opportunity, to help different, clients to move to the cloud, or even just starting from scratch in the cloud, right? Building the cloud infrastructure. Another trend that we've seen in the last few years, and I believe it's going to last for many years as well, is the modern data stack. Right? I think I briefly talked about this when I introduced data engineering tonight. 5 trend, right, for data ingestion, and ELT, right, in Snowflake using DBT, and also the reverse ETL using high touch. This is a pretty standard suite of tools that companies like to go with. It's not cheap. You end up paying tens of thousands of dollars on a monthly basis, maybe. But if your company is at the right size, and if you can afford this kind of tools, I think at least at the very beginning, you'll end up saving a lot of time. Because imagine you don't have 5 trend, then the company will probably need to hire 2 to 3 data engineers to write connectors or work, setting up open source tools. So the human capital cost is also very high. But working with 5trend, you pretty much have access to more than 150 data connectors, and that should cover most of the SaaS tools the company work with, right? And if you would like to ingest web analytics tool, then you might be working with, Segment. A lot of companies use Segment, but you can go open source as well to work with Snowplow, for example. But typically, data will be ingested into Snowflake, a data warehouse, and all the transformation and loading happens in Snowflake using DBT. So these are working pretty well right now, and a lot of companies, it's a no-brainer for them to adopt the modern data stack. And of course, for companies that deal with big data, and also companies who have a lot of unstructured data, they will probably go with a data lakehouse approach. And it's still pretty advanced, I would say, for many companies, because companies such as banks, retail companies, or telecommunication companies, they have adopted Hadoop and data lake, right, 8-10 years ago. So Hadoop nowadays become the legacy systems. When companies migrate to the cloud, they may actually just go with Amazon S3, Google, storage, instead of going with Hadoop, unless you have tremendous amount of data, and Hadoop may still make sense. But yeah, the new trend here is Apache Spark data lakehouse, using Apache Iceberg and Apache Hudi. There are a lot of things you need to learn here, and programming will be required. And so if you come from IT background, and your current job, let's say you did IT support, you don't write a lot of code, I would recommend starting from, for example, analytics engineering. Or if you're very interested in, big data, streaming data applications, then you basically will need to learn a lot of programming, right, in a short amount of time. Pick up SQL, Python, learn a little bit Scala. I think these will be the prerequisite if you want to become a big data engineer, for example. As I said, there are different schools of thought right now. Data warehouse is pretty popular. I think when big data came out, right, Hadoop and Spark, and there was a certain period where SQL just lost its appeal to many companies, and because big data is a buzzword, and every company wants to do big data, doing distributed computing, so they will be using different tools such as Apache Spark. And data warehouse, the traditional data warehouse, right, built on top of Oracle, for example, Teradata, are considered to be like legacy systems or tools. But somehow SQL is having a comeback in the recent years because of Snowflake, I think, and its new ecosystems called modern data warehouse, right? And it's powered by cloud, and also the separation of storage and compute, which is really powerful idea. And some application just makes sense, on data warehouse, and it can even save cost. But if you look at data lake, and for most of the company considering data lake, storage will definitely be cheaper, right? The starting cost of a data warehouse and Snowflake is actually quite high. But you get all the flexibility with, data lake and, lower cost. But lower cost on the infrastructure side doesn't mean lower cost on the, human capital side, because now you need programmers or data engineers who can really code. While on the data warehouse side, you just need people who are really good with SQL, and everyone loves SQL, right? So there you can find so many more SQL developers out there compared to someone who can write Spark and Scala code. So companies, I think, always need to make decisions based on their team capability as well, unless you just rebuild the whole team. Lakehouse on the right-hand side is a new trend in the data lake side. I think data lake sometimes can get clunky. It was very promising, right, when Hadoop was invented, but it didn't really deliver that promise, of big data, and it didn't work very well in the streaming world. And companies are starting to build more and more streaming applications, and this is where data lakehouse comes in, and to add that asset feature to data lake, and I think it's just the next generation of data lake, and it's very promising, I think. So yeah, some new trends to watch out to. And another trend I would like to share is the serverless data engineering, and it's a very interesting idea. And some people are actually against this idea because you end up building very complicated systems, and if every function you run is serverless, and you're gluing together all of these different functions, yeah, and sometimes the cost may actually even be higher when you're dealing with really massive amounts of data. So again, I think companies will need to make the right decision to see which approach that makes sense. I've even read blog posts of companies saying that they've switched completely to serverless data engineering. I found that interesting, but I think it must be really hard to build. But this is new trend as well. I don't think it makes sense from my perspective to build everything serverless. But I've certainly worked on many projects that have serverless or Lambda functions as part of the pipeline. So I think for data engineers, when you work with AWS Lambda, this is where you need to understand a little bit, DevOps, like working with containers. You're writing your code and deploy that in containers. You might be using the serverless framework, so you need to do some sort of configuration, right? And then you can version control your config files and things like that. A little bit, operation side of things, but it's not very hard to learn if you want to, apply Lambda functions and stuff in production. And this is just one of the examples that I adopted from AWS blog post. It's something certainly interesting that I think worth looking into. Okay, so let's talk about how to transition from IT to data engineering. First of all, if you come from IT, background, right? You may work in database in databases. You might be a database administrator. You may come from IT support background, or you already work as a data engineer. Maybe the title is ETL developer or ETL engineer, working on data stage, some traditional tools, right? Or you're a software developer, a software engineer, or you work on the infrastructure and platform team. And if you're interested in data engineering, right, or a lot of companies are cutting IT budget, right, because they're moving to the cloud and they sort of need a different type of talents, and there will be new opportunities even in the same company if you'd like to internally transfer to a different role. In that case, if you find data engineering interesting, here will be my suggestion. For database experts, if you would like to work as a data engineer, it all depends on your end goal. If you want to work on Spark and building real-time applications, right, no problem, just spend more time. But the way I write these, tools, right, the sequence is, I think if you come from a database background, get into modern data, engine, or whatever, modern data warehouse or the modern data stack is probably a short path, right? It's because you're very, you understand database internals, even though a lot of database administrators actually don't write a lot of SQL queries to analyze data. I get it, but I think you still have a much better database background than most people. So if you understand data modeling, getting into modern data stack world is much easier because your strength is still in SQL. Now you just need to learn DBT and understand the data flow, right? How data is ingested. You can, and a lot of companies working with modern data stack, they actually just use vendor tools such as Stitch or Fivetran, for example. And so that would be my recommendation. Or this could be the sequence of learning. You can start from learning, DBT, for example, and data ingestion. But I think definitely if you want to work in data engineering, there's at least one programming language you need to know, be very good at, which is Python. So working as a database administrator, you may not write a lot of Python scripts. You may do it sometimes, but not extensively. Definitely brush up on your Python programming skill so that you can work with, for example, pandas and PySpark, right? You should definitely look into distributed systems such as, Spark and Databricks. I think as a data engineer, you'll have to know these tools. There are companies that don't use big data tools because they probably don't need it. But I think if you want to stay competitive in the job market, you need to learn Spark, right? And at least one of these cloud tools, platforms such as AWS and Google Cloud. So that at least, instead of maintaining and working with, your PostgreSQL or SQL Server on premise, like how to do that in the cloud using RDS, it's a lot easier. But of course, I know for mission critical systems, some companies will probably not trust cloud, and their beefy database, tools and service will probably play a very important role in their current company. But I can bet that the company definitely thought about moving to the cloud. So I think for database experts, moving to the cloud, you will still need to do some sort of cloud certification courses. I think understanding how database systems work in the cloud. You might, you used to deal with row-oriented database, but now maybe consider learning some, column databases such as, Amazon Redshift and Snowflake. So that would be my recommendation for database experts. And if you come from IT support background, and I think you can probably start from Python and SQL. I think coding is definitely the relatively weak points. You may come from a computer science background, but your 3 to 5 years of work experience is not really focused on programming that much. So you definitely need to start from coding, right? Python, SQL, and then pick up cloud. And start to learn more about big data and automation. And when you work IT, sometimes you work on automation. And what I meant here was, how to automate data pipelines. And again, you will be most likely working with Python-based tools, for example, Prefect, Dagsters, Apache Airflow. These are the 3 most well-known data pipelining tools. They're all Python-based. For professionals who come from the traditional ETL background, I think it's quite natural, right, for you to switch to the modern data engineering. It's probably not that hard for you at all. It's really just about upskilling yourself, like learn more about Python and Scala. If you used to work with Informatica, like you use GUI-based tool, then you'll probably need to put more effort into learning coding. And learning cloud is something I would recommend as well. Yeah, if you work in ETL or you used to work in ETL, you'll definitely need to learn Apache Spark because your strength is your understanding of the complexity of the data and different kind of transformation, approaches and data modeling. These are your key strengths because there are data engineers out there who's really good with coding and different tools, but when it comes to actually writing the code to transform data, they actually don't do a good job. So this will always be your strength, right? And it looks very relevant on your resume anyways. And you'll definitely need to learn Apache Spark so that you can demonstrate your skill set working with open source, projects. And since you had a lot of batch oriented, ETL experiences, try to learn streaming data processing using Apache Flink or Spark Streaming, and then actually you'll want to learn more about lakehouse architecture. So that's the suggestions for ETL experts. And for software engineers and developers, I think I've worked with a lot of software engineers, and they found, data engineer not very exciting, because they feel like they're not writing a lot of code, and a lot of those code are scripting. It's not really writing any sort of real application from their perspective, right? But you have to understand, you're building data applications now, so that is different, right? But if you like to do more coding and you still want to work as data engineer, I would recommend picking up Scala. That's always going to give you an advantage. A lot of the distributed systems are written in Java and Scala, such as Spark and Flink, right? So start from functional programming Scala, and you definitely need to learn cloud, right? And the focus could be more on the streaming application side and working with Kafka to do real-time to build real-time systems. So that means you need to learn more about data system design as well, right? Using distributed systems. For folks coming from infrastructure and platform background, you're probably very familiar with like cloud and containers already. So my recommendation would be learning or just like focusing more on the serverless, because it touches on infrastructure, and you can sort of transition to a more data architect related roles. And learning distributed system will always be useful, and data lake and lakehouse. These are some of the things I would recommend. You probably wouldn't enjoy writing SQL queries that much, but everyone's different. So that's just my generic way of explaining or recommending, the learning path for people coming from different background. Okay, so I think I missed a lot of questions here. So I'll pause here for a bit, and I'll try to answer some questions. I'm curious why Databricks does not show up more often on your slides. I heard that they're doing a good job processing. Databricks, we teach using Databricks a lot. I used to work with Apache Spark a lot myself as well. So whenever I mention Apache Spark, that probably just, you can use Databricks to replace that. So Databricks is just a vendor, right? It started from an open source project called Apache Spark. The CTOs and the co-founders of Databricks are basically the original inventors of contributors of the Apache Spark projects. And now they are also heavily involved in the data lakehouse, right? So I mentioned like Spark and Lakehouse a lot today. And one vendor you can work with is basically Databricks, right? But I also mentioned that for Lakehouse, you can work with Iceberg, you can work with Hudi. You don't really have to go with Databricks. But Databricks is more like, nowadays I think it's sort of evolved into a more end-to-end data science platform, right? The end goal of Databricks is to help companies to generate value from their big data. They started from a distributed system, they built the lakehouse, but ultimately I think working as a data engineer using Databricks, they're doing like a lot of Jupyter notebook stuff, like using Databricks notebooks, writing PySpark jobs. Yeah, but when I mentioned Apache Spark, Databricks is definitely considered there. Thanks, Tarek, for explaining it. What would be the job roles that work with Databricks? Would that not be DEs? So Databricks can be used by different data roles. Like data engineers will be using Databricks to do streaming job, data transformations on streaming data, writing ETL Spark jobs. But a lot of people using Databricks are actually data analysts and data scientists, because data scientists will be Databricks actually, I think two years ago, they acquired an open source data visualization tool, right? I think it's called Redash. So it's basically, similar to Tableau and Power BI. So they're focusing on the analytics side, even though they started from a distributed system, right? Apache Spark. So Yeah, a lot of data scientists use Databricks tools, and they have notebooks that works really well for I think most data scientists like it. And in Databricks platform, you're essentially using Spark to write, PySpark jobs if you're a Python user, but you can write Spark SQL. I think that this is probably old statistics, but I think 70 to 80% of the production Spark jobs are actually using Spark SQL instead of using Scala or Python. I could be wrong, but yeah, Spark SQL is also very important, very popular. Databricks also has certification on like, Spark developer or Databricks developers, and they have certified data scientists as well, I believe. Yeah. Yeah. The founders of Databricks are from UC Berkeley. Yes, exactly. And interestingly, I think the same lab are promoting another project called Ray, right? You can go to ray.io, and the commercial company, I believe it's called Anyscale, and Databricks is somehow involved in that as well, because I think one of the Databricks co-founders are also the co-founder of Anyscale. So that's interesting. It's a distributed system as well, but Ray is more tailored, targeting data scientists and machine learning engineers, which is a very cool platform. It's already powering OpenAI and companies like Shopify already. Yeah. Thanks everyone for the great discussion here. All right, so how to get started with data engineering? I would like to recommend WeCloudData's data engineering curriculum. So we cover a lot of data engineering tools. First of all, it all starts from programming. I think as a data engineer, you need to be familiar with Linux command line. You don't need to be an expert in operating system. You don't need to be an administrator, but at least the command line, because you'll be working with like bash and shell scripting a lot when you run Python scripts and run Spark jobs. And but of course, depending on the environment, if you work with AWS, you sort of need to work with command line as well. You need to know SQL and Python, but these are sort of like the prerequisite. So if you come from IT support, or you don't program a lot in your current job, I definitely think you should focus. I think if you come from IT, Linux is no brainer. Like you're pretty good with it already, but you need to pick up Python and SQL. And I make Scala optional here because I know there's some data engineering team, they have pretty strong Java and Scala culture. But in recent years, I saw like Python and PySpark becoming sort of more popular and dominant. I think even though PySpark was originally written in Scala, PySpark has sort of become more popular in production. That's my understanding. I think it was a paper or whatever article published by Databricks themselves. And then we start from so for WeCloudData's data engineering bootcamp, SQL and Python are the prerequisite. If you don't know SQL and Python, we have we have pre-boot camps, so you can join the program to practice SQL and Python. But if you're taking this curriculum as a self-learning guide, I would definitely like recommend you spend more time on SQL and Python, because I think like in most of the interviews for data engineers, you'll be given like a SQL test or Python assessment for sure. Cloud. So after you've learned Linux, right, some Python programming, I think you need to get familiar with infrastructure and platform as service. You can start from AWS, but you can pick up Google Cloud and Azure. My only recommendation here is that you don't need to be expert or masters of all three of them. Definitely just focus your time on learning one of these platforms and get good at it, and maybe get certified. But it's not necessary for you to get certified in all three clouds. I've seen on LinkedIn there are a lot of like discussions. There are people who get like multiple cloud certifications. They're still struggling to get a job. And I think one challenge there was to become a solution architect, and even the AWS solution architect exam would require like sort of 1 to 2 years of experience working with cloud. So if you're just doing this for the sake of certification, you can't really demonstrate your real experience. And if you know cloud platforms, but you haven't worked with like building data pipelines, you still can't get a data engineer or data analyst job. So most of the data engineers are just using cloud as the tool or the backend infrastructure, but mainly they're still working with SQL and Python to analyze and process data, right? So the focus should still be on data, but I think data engineers should know, the very least, understand, how to set up EC2 instance, how to store data in S3, and how to use Python to, the Python API, Bodo, for example, to interact with storage systems. So you don't just like click on the button in the GUI in the console to upload and download data. You should at least be familiar with like the command line, like AWS CLI, to move data around, and that's important skill to have, right? You need to be pretty comfortable with that. And then I think, as I mentioned, like serverless, data engineering, but serverless is being used for many different purposes. Definitely data engineers and even cloud engineers need to know how to work with Lambda functions. And if you ingest data in real time through Kinesis into S3, you can use Lambda to do some sort of data transformation on the fly, right? There are event triggers that allows you to do that. So understanding Lambda is important. And yeah, we need to learn EMR. So EMR is Elastic MapReduce. So that's basically the Hadoop cluster in AWS. So if you want to run Spark applications, you can run that on EMR, but you can use Databricks as well, right? Of course, EMR is a lot cheaper than Databricks, but you don't get the fancy features provided by Databricks as an integrated solution, right? But a lot of companies would probably go with EMR to save cost. And Athena is sort of like, serverless distributed SQL query engine based on, Presto. But open source project nowadays is called TrinoDB, if you've heard of it. It's pretty popular as well. Yeah, so that's cloud. And I would recommend like doing all of your projects in the cloud so you get to practice, your cloud computing skills. But you definitely don't need to focus too much on like building VPCs and, the security networking side of things. And next we'll move on to data warehouses. I think after, even though to build an end-to-end data pipeline, you start from data extraction and ingestion, but in this case, after learning SQL, we would recommend starting from databases, right? Data storage in relational database. So this is where you need to learn relational databases, the basic data modeling, and also dimensional modeling, and if you're building data warehouses. So you'll definitely need to work with Redshift or Snowflake to gain some hands-on experience doing some exercises and labs on that. It will be great if one of your portfolio projects is basically using dbt and Snowflake to build some sort of data models in your data warehouse. Okay. And after learning data warehouse, I would recommend moving on to big data, right? If you look at most of the traditional companies, they started from data warehouse and databases, and then they started to adopt big data. I don't think you need to spend a ton of time on Hadoop. It's just a distributed system. I think you need to understand the core MapReduce concept. Some companies still use Hadoop and Hive and Spark, right? But I think understanding the core concept of distributed system will still be very helpful. And that's going to help you when you're writing and tuning Spark jobs, whether it's on Databricks, or using Glue, right? AWS has a Glue service, and it's basically part of it is serverless Spark. So you don't really need to run your Spark jobs on, Databricks. You can just do that in a serverless fashion, and you're basically Glue is launching like Spark clusters on the fly just for you to run the jobs. I did that. It was quite expensive, to be honest. So I don't like it. And NoSQL, I think data engineers will definitely need to know at least one NoSQL database, right? You need to understand the differences between a relational database and NoSQL database. and relational database is more ACID, and NoSQL database, go with the CAP theorem. I think these fundamental concepts, you need to understand that. But depending on the use cases, right? Because when you enter the NoSQL world, it's very confusing sometimes, right? For NoSQL database alone, then it has multiple categories. It has the key value store, in-memory caching using Redis, Memcache. And there's the columnar database, such as Cassandra and HBase, right? There's key value store such as DynamoDB, and there's document database such as MongoDB. Elasticsearch is considered as a NoSQL database as well, right? But it's full text search engine database. And MongoDB can be used for document search as well. And nowadays there's the graph database as well. And every time it feels like you're learning a different type of database. It is. So you don't need to be expert in all of these, but I think you should definitely at least be familiar with one of the key value database, such as Dynamo or Cassandra, right? And if DynamoDB is recommended here because our curriculum has a focus on Amazon Web Services, and Dynamo is also one of the earliest NoSQL database, and Cassandra is sort of coming after DynamoDB. And Elasticsearch is very popular, right, in enterprise search applications. A lot of big companies use Elasticsearch. I would highly recommend data engineers learning Elasticsearch. And it can be used for machine learning and data science purposes as well. Yeah, so these are the tools I would recommend. And when it comes to big data, I think you need to know Presto and Athena. And I think all of these are distributed systems. They're built for the scalability, right? Working with Presto and Athena, the backend, I think infrastructure framework is very complex, but it's basically just writing SQL, so it's not very hard to work with. And then we need to meet the most important component in your data engineering learning journey, which is the actual processing of the data, right? Because you can learn a bunch of tools, cloud and big data, but still not good at processing data. And the most important key skills a data engineer need to have is actually understanding the data structure, data models, and just figure out how to model the data and merge, join, aggregate the data, right? And also write user-defined functions to process data or transform the data. So that includes, right, data ingestion. And of course, here you need to understand the differences between ETL and ELT. I think I had a typo there. Yeah, it should be ELT. Let me actually fix that quickly. Yeah, so in a modern data, stack world, right, you will be working with the ELT concept, which means data will get loaded into Snowflake data warehouse directly first, and then you do auto transformation inside the warehouse. When your data is really massive, that could be quite expensive, right? Storing all the data in Snowflake. So there's still a lot of companies going with the traditional ETL approach, which sort of makes sense, but sometimes it looks like ELT as well, because instead of ingesting data directly into the warehouse, you can ingest that into Lakehouse or your data lake, right? And then you apply the transformation. So it just depends on your understanding of what is the loading part means. Does it mean loading data into a warehouse? It could be loading data into a data lake, then a lot of systems actually look like ELT, or sometimes it's ETLT or ELT. It's funny, but yeah, you can have a different ways of building your data systems. Okay. I would say that with the first semester, you can probably you have the right skills to get data engineer jobs. You don't have to know all the advanced stuff, right? But the complete curriculum also includes data lakehouse. It's getting more popular, right? You need to understand, I think at some point, data engineers will need to become data architect. You need to understand the high level workflows and architect, right? So lakehouse, sort of like building something end to end, you need to understand the lakehouse architecture. There are different tools you need to learn, such as Hoodie and Delta Lake. And Kafka is playing an important role here as a distributed messaging queue, right? So a lot of times you're ingesting data into Kafka, and then you're pulling the data for downstream processing. And data pipelining is also very important. And I think a lot of interviews involves Apache Airflow as well. Sometimes employers will ask you to draw some sort of Airflow DAGs just to explain how you would transform the data, the workflow. And I've even our students even came across interviews that require them to actually deploy small Airflow applications. They will ask you how did you deploy your Airflow? Because there are different ways or different modes you can deploy Airflow in production, right? And based on your deployment, options, then they can pretty much tell at what scale are you running Airflow pipelines in your previous job or company or in your personal project. And dbt is just another tool in Snowflake and the modern data stack for you to write SQL queries to build models. And I think data engineers will need to understand version control and the basic concepts of CI/CD, right? Because you may want to do automated testing on your Airflow DAGs and your Spark applications, right? A little bit CI/CD will be helpful. And sometimes you need to, and I think because data engineers will a lot of times help the company to decide, do some sort of benchmarking and experimentation, right? To decide if some tool is the right tool, and you have to read documentation. Let's say your company wants to build a customer data platform or CDI, and you can pay a premium, amount of money to for Segment, but your company may actually want to or prefer to keep all of the data in your own cloud infrastructure. So you don't want to send all of your customer data directly to a different vendor platform. So in that case, you may want to take a look at Snowplow, for example. And Snowplow can be deployed on Kubernetes cluster. You can run that in a single Docker container, but it's not production ready, right? So in that case, you probably need to, you find yourself working with Docker containers from time to time. If you work in a small team, and of course, if you work in a big company, data engineers probably don't need to worry too much about it. And data governance, I think understanding data governance is important because this is a topic that every company will talk about at a certain point, right? Part of data governance is just the people and process, and just, you have data stewards writing and owners writing the policies. I think data engineers sometimes need to provide consultation, right, to the data stewards. They're not that technical. And you'll basically be working alongside the data governance team, right? And they will design or set the the policies, but data engineers will need to understand those policies and use that when you build your data systems. For example, data quality, right? There might be specific requirements in your industry, for example, healthcare, right? How to control data quality, and how to protect user data, what kind of hashing algorithm you need to use, encryption, and things like that. And from a governance perspective, understanding data catalog is also very important in the big data world. Sometimes a company don't want to adopt some open source project because of that, because it doesn't meet their data governance requirements, right? Amundsen is an interesting project I recommend everyone looking into. Right now, it works better with AWS because it started from AWS. But yeah, it's pretty interesting data cataloging tool. There are some other similar tools out there as well. Metadata management and also data privacy. So some of these, I think you can read some blog posts and articles on it. Definitely invest some time on it. The best way to learn about these, because it's kind of hard to learn data governance if you don't actually work in a team that use it or apply it. I think that the shortcut of learning more about data governance is just go find the vendors that provides data governance solutions and read their white paper, because they are constantly advocating for their product, and they have to be that expert that provides the know-how right, to their potential clients in the future. So you can learn a lot from those articles and blog posts. And project management. We touch on that a little bit when the student start to work on real projects, but we don't cover that extensively. And if you come from IT background, I think you understand project management very well already. All right, cool. There are some other questions. I'll leave that to the end. I think we're almost there. So to become a data engineer, right? First of all, I think you need to sort of follow a curriculum. Hopefully, this curriculum is useful for you. But I think, you know, to get a job, you definitely need to work on some projects, right? So I think whatever portfolio project you build or some practice you do, right, while you're working, like learning these concepts, try to work on something end to end, right? So this is reference architecture that I created, and it's I read a lot of AWS, you know, architecture, best practices, and put something together that looks pretty similar to what they have. But this is actually similar to one of the projects we worked on, but we did that in Azure instead of AWS. Even though in our company we built all the internal tools on AWS. So if your project can touch on, you know, maybe 50% of this, I think it will look pretty good, right? It's hard to build something completely end to end. For example, it might be hard to replicate, like, you know, an on-prem environment. But maybe you can, like, you can set up a server yourself. But definitely think about data ingestion and collection, right? DMS service is AWS Data Migration Service, right? And you have data sync, which is similar to, you know, I would say this is like the 5 trend in AWS, right? You can sync data from databases, right? To sorry, AppFlow is more like 5 trend, and data sync allows you to sync data from other data sources as well, right? Ingesting data from SaaS, like maybe you don't need all 4 different sources, but in your data engineering project, definitely you know, try to work with a SaaS tool, do some sort of web scraping, work with APIs such as the Twitter API to ingest data. And if you want to ingest data in real time, right, you may want to spin up an EC2 instance so that you can run the application, Python applications to collect data, and then you put that into a Kafka or Kinesis queue. And this is where the data ingestion starts, right? You want to ingest the data into S3 as the raw data, and you might want to use Glue, right? Because it has a crawler and catalog. There are a ton of good resources and tutorials out there as well. But I think understand like the best practices is important, right? Like, you know, if you work for a bank, they may ask you like, you know, why do you need a landing zone, right? And you need a processing zone. And these are some of the practical considerations. And you can use, you know, you don't really need to have massive amounts of data. Like even when you have, like, you know, even if you have a small amount of data, you can still launch a Spark cluster to process the data. And at least you want to, you know, demonstrate that you have this end-to-end understanding of the data pipeline. And of course, try to automate this pipeline using Airflow, or you can use Lambda functions and, you know, step functions to do something similar as well. Okay. And also, a lot of people ignore the part of, you know, visualization. I think data engineering projects are very hard to demonstrate because it's just a bunch of code. So one thing that was make your portfolio stand out is just your data pipeline diagram and architecture. But if you are building modern data stack application, for example, for your portfolio project, then the end goal might just be a dashboard, right? You're building all of these, you know, DBT models to refresh a table that allows you to do BI. So maybe try to do some visualization as well. I think it will be helpful. Okay. Okay. So one thing I would like to point out is that you feel like you're learning a bunch of tools, you know, along the way, and you still don't know how to connect them together. That's the common pain points of learning data engineering, like so many tools, but how do they work together, right? So that's something I think you need to pay attention to. But you should always understand a little bit more about the business. By business, I mean, at least understand like, for example, like when we work with Fivetran, which is essentially just a connector. If you have the IP address, the ports and the credentials, like you literally don't have to write any code, right? But if you're ingesting Salesforce data, right? As a data engineer, I think you need to understand how CRM and how sales pipeline works at a very high level. And then when you look at the Salesforce data model, right, you can find that on Fivetran documentation for the connector, and it will probably tell you that there are 40 different tables. Look into that because that's very much business related. And you do need to understand like the data models, right? How it's engineered in the source systems. And because working as a data engineer, it's just not just about working with the tools. Eventually, you need to dig into the data, the messy data world, right? I think too many people, they just learned a bunch of tools and they failed interviews because they've actually never worked with, the real data. And the real world, like when you work on real world data warehouse projects and you start to realize that the tools don't matter. You can use SQL, you can use fancy databases like Snowflake or, and Spark, whatever. But if you can't write SQL and you can't understand like the data models and how the data is structured and stored in the database systems and how to merge and join them, and you can't be a good data engineer. So I think understanding business logic is important because every transformation query you run, it has some sort of business logic in it, right? Understanding data models, I think it's very important for data engineers, especially the analytics engineers working with the modern data stack. Yeah, and you need to learn coding, get comfortable with Python, SQL, Apache Spark. I think automation. On the infrastructure side, I think you need to learn AWS or Google Cloud, right? All right, that's pretty much it. And WeCloudData has a data engineering bootcamp, and you can go to our website. But this is a bootcamp, part-time bootcamp. It runs for 6 months. It happens, Thursday evening and Sunday. So, you spend 10 hours a week with us. There'll be 6 hours of lectures, and then 4 hours of hands-on labs. And students will get pretty busy working on 2 end-to-end projects that are pretty comprehensive. I'll share a link with you so you can check out some of the projects our students built in the past. But this is a program built for career switchers and new grads. There are quite a few students in our programs that are newcomers. They work in data and IT already, but they're learning, upskilling themselves as well. And there's some data scientists switching to data engineering as well. And WeCloudData's advantage, I would say, compared to the online courses, traditional boot camps, and of course, I think we have pretty solid and probably the most advanced curriculum out there when it comes to data engineering. Students will complete 2 very big portfolio projects, and after graduation, the program itself is 6 months, and student will have an additional 6 months working one-on-one with industry mentors who work in the data engineering field, to work on resumes and job search. So we support job search for 6 months after graduation, and students also get the option to work on real client projects. It's just an additional option, a course you can take, but yeah, if you have time. But this is a real client project course that allows the student to fill the experience gap. If you don't really come from IT background and your resume probably doesn't look very it doesn't look very relevant to data engineering, even if you have the certification and know a bunch of tools. So working on real project allows you to add real experience to your resume, and that really helped a lot of our students get jobs. Okay, all right, so I think that's pretty much it. The only thing I would recommend at the end is just go to youtube.com and /@WeCloudData. You will be able to find some of the past event recordings. And if you would like to check out some of our students' final project presentation. Most of those presentations are related to are built on top of AWS and using Hoodie and Kafka. So yeah, I think most of those are, maybe I'll show you, see if most of these projects are Lakehouse projects. So you can go to playlists and find data engineering project. And yeah, so for example, this is one project built by a student. What's interesting is, every student will always think about, like, they're way more creative than we thought. Because at the very beginning, we give student a blueprint, right? We teach them how to build this. But then we thought that the project may always look similar. It turns out that every project is different. For example, this student, he loves gaming. He's playing games, right? And he's actually collecting data from this game's API, and he had a hard time learning C#. He's not a C# programmer, but because he's like so into games, and he actually learned the C# in a couple of weeks and ingest the data into S3, and it built a simple, like, fast API application deployed on Docker. We covered NiFi for data ingestion, and also Debezium, and this is the change data capture side. You'll probably notice that the students over-engineered, right? In real world application, it may not look like this. It might be simpler, or but they're trying to put everything they've learned together, right? For real-time data ingestion, if you want to work with data lakehouse, you need to capture change data from databases. So that's why they set up a Docker container to set up the change data capture, and data gets ingested into Kafka, and then they use Spark Streaming and work with Apache Hoodie. And in the end, they use Superset. Again, you'll notice yourself working with a lot of Docker containers here, because there's just no time for you to build all of these, like, set everything up from scratch. But this is a pretty interesting project, and it's created by a student who has never done programming before joining the program. So that was pretty impressive. This is a student who complained all the way, until the end about the program, but we're super happy about the outcome. And he got 2 job offers, so we're super happy for him. So yeah, you can go check it out. And you can find some project presentations. That's pretty much it. Yeah, we do have a Discord group. One second, let me share a link with you. Yeah, so we're doing and I think every Friday evening we have some free data courses, like workshops. So I think tonight it's more like information session, but on Fridays we usually run like hands-on sessions. So if you would like to learn, like, SQL, Python, and Tableau, we can definitely join the Discord channel, and you'll get notifications. And we're building a website for that as well, so you'll have, you can easily explore, like, upcoming courses and things like that. Yeah. The slides, this presentation will be available on YouTube. Let me send the YouTube link to you. Cool. Yeah. So yeah, if you're interested in WeCloudData's data engineering bootcamp, the next cohort starts in February, and then after that there will be we have the April and May cohort. Definitely come and talk to us if you're interested, and see if WeCloudData can help you. Okay, so we're at the end. If you have any other questions, feel free to ask. I can stay a few more minutes if you have questions. I think I missed a question from Amit. Could you please elaborate more on modern data stack? First slide on how to use tools for analysis. Can let me find that slide. Do you mean this one? If you're still around.
Before this.
Oh, before this? Okay. Which one is it? Okay. Do you mean this image?
No. I think it was the one you brought before. Then you changed it.
Okay, let me
Brought
flip
data
that.
tags. Yeah. Before this. Before this.
Oh, before this one?
Yeah. Yeah.
Oh, this slide is the on-premise to cloud migration. This is not necessarily something new, but I think it has a lot of potential, right? Because a lot of small to medium businesses and also big companies are migrating to the cloud. So that's why I think the demand for cloud engineers will be pretty big in the future. But along the way, that also creates a lot of opportunities for data engineers because in some companies, data engineers actually just work on data migration projects. And of course, data engineers and cloud engineers in this case will team up because we need cloud engineers, right, to decide the best practices, right, to make the infrastructure secure. And that's more on the IT side. But when you actually do the migration, right, you need to do the schema migration. For example, if you have an Oracle database you would like to migrate to the cloud, some companies may still choose to work with Oracle deployed in Amazon Web Services. But in that case, you're sort of just doing like something pretty similar to what you did on-premise, right? So many companies will at least consider a different kind of cloud data warehouse or databases. For example, you can use some RDS database, or you can use Amazon Redshift, for example, if you want to do data warehouse migration. So you're basically moving data from one database engine to a different database engine, right? And that is actually not that straightforward. You have to do the schema migration, right? And you have to match all the column names and data types and those kind of things. And data transfer is also a big concern here, right? Some companies will have security requirements, and some companies may have like really big data and the internet connection speed is the bottleneck. And Amazon has many different services that allows you to sort of transfer data into a cloud data center quickly. And there's tools like Snowball and Snowtruck. But I think data engineers may work on the actual migration, right? And they have to do a lot of data profiling to make sure that data gets migrated over to the cloud is what you want, and you have to tune those data models and to make sure that it achieves the performance you want. So I see that as a good opportunity, even for consulting projects. So that's what I meant.
Okay. Thank you very much.
Thanks, Tariq. Any other questions? Definitely stay in touch on Discord because we have quite a few events scheduled for February and March, and also we have free open courses on Fridays going forward. So yeah, I look forward to seeing everyone in those workshops. Thanks for your time. Thanks for joining this session. I hope you liked it and learned something. And yeah, I'll see you guys around. Take care, guys.
Thank you.
And someone was asking if we can be connected to existing students or alumni. Absolutely. We can definitely connect you with our alumni if you would like to learn their learning experience. So yeah, come talk to us. All right. Have a great evening, everyone.